So it's now time to turn our attention to the client side of the PrimeCheckApp case study. In particular, in this part of the lesson, we're going to describe the structure and functionality of the PrimeCheckClient that sends and receives HTTP GET requests and responses to and from the PrimeCheckApp server, in particular the PrimeCheck controller and PrimeCheck service that we talked about recently. The PrimeCheckClient class performs synchronous remote method invocations on the PrimeCheck controller to determine the primality of large integers. You can get this class here at this implementation link below at the bottom of the slide. It has a component annotation which tells Spring to enable auto-detection and wiring of dependent implementation classes via the Spring class path scanning feature. This feature is actually used here because we're going to end up auto-wiring something called a request template. The request template is something that's auto-wired using Spring's dependency injection framework, and it's going to be used by the various methods down below in order to make synchronous requests, GET requests in this case, to the PrimeCheckApp server. The first method we're going to look at briefly is called test individual calls, and it's used to send individual HTTP GET requests from the client to the server. And you can see it takes a list of prime candidates as well as a Boolean parameter to indicate whether parallelism should be used in the implementation or not. If we take a look at this particular method, you'll see that it uses this clever trick I've talked about a number of times before that conditionally enables either a parallel or a sequential stream using a parameter that's passed into the test individual calls method that's a Boolean. So the basic idea here is that any parallelism that's requested by the caller is going to be performed by the client rather than by the server. We'll see that that's going to change with the other method, the test list calls method that we'll talk about in just a moment. But in this one, test individual calls, any parallelism that's done is on the client side, not the server side. There's a little helper method here that we'll look at when we look at the source code in more detail called MakeCheckIfPrimeURL, and it basically takes in a prime candidate and it gives back a URL that can be used to make a GET request to the server to determine whether an integer is prime, in this case, the prime candidate. And at the bottom of the slide, I have an example of what such a URL might look like coming back from the MakeCheckIfPrimeURL factory method. And it includes, as you can see, the address of the server and the port number it's listening on, an indication of what endpoint method to call, in this case, checkIfPrime, and then the prime candidate, which in this case is going to be a large random integer. The invocation that's actually called to send the request from the client to the server is done with another helper method. This is called MakeGetRequest, and it's part of my WebUtils utility class. And this particular method makes the HTTP GET call to the server using the URL that was created by MakeCheckIfPrimeURL. And the basic idea behind this is to shield the client code that we're looking at here from the lower level HTTP programming details. We will look at the implementation of MakeGetRequest when we do the code walkthrough in the next part of the lesson. Now let's turn our attention to an overview of the test list call method. This is the client method that sends a single list of integer objects in one HTTP GET request to the server. So unlike the previous approach where we sent a bunch of requests, one for every integer, this is going to make one request, one fell swoop, as I like to say, and send all the information over once. The other thing that's going to happen here, based on the parameter that's passed in, it's called parallel, whether that's true or false, is that any parallelism that's requested by the client will be performed by the server rather than by the client. And that's also the reverse of what was done with the test individual calls method that we just looked at, where the parallelism, if any, is done on the client, not on the server. In this case, parallelism is done by the server, not on the client. And in the next couple videos, we'll take a look at the implications of this, and we'll eventually show the timing results so you can see what's better, doing it on the client or doing it on the server. There's also another helper method here that's part of my WebUtils class called list2string, and this takes the list of integers that are the prime candidates, and it converts the list of integer objects into a single string of comma-separated integers encodings. So it encodes the integers so that they're basically going to look like what you see at the bottom of the screen, where it's just a string of these encoded integers with commas separating them. And then if you take a look here, there's another method called MakeCheckIfPrimeListURL, and that's going to create a URL that's going to be passed via the HTTP GET request to determine the primality of this string of comma-separated integers. And in this particular case, it's going to encode everything we just saw, plus some other stuff at the end indicating that parallel is in fact true, if that was the case, if that was the caller's intent. In this case, we're going to use another utility method called MakeGetRequestList, which makes a single HTTP GET call to the server that contains, as part of the URL, all the encoded prime candidate values. And once again, this helper method helps to shield the client code here from the low-level HTTP programming details that would otherwise distract us from the business logic part. So there's still a little bit more code here than would be if you were just making a local call from a client in the same address space to an object in the same address space, but it's not gratuitously bad. It's kind of abstracted away a little bit and encapsulated so it's a little cleaner. So that's the end of this next part of our case study, where we focused on the high-level view and the high-level structure and functionality of the client. Next, we will take a look at the more detailed walkthrough of the code itself.